Alright guys, in this video we are going to be talking about arrays in MATLAB. And the first question one will ask is, what is an array? Array is basically a collection of numbers, or not necessarily numbers. It could be objects, but mostly in MATLAB you'll be dealing with numbers. So yeah, array is basically a collection of numbers, and this collection could be in the form of a matrix or just a list of numbers. For example, you can write something like this, just as you write in math, a matrix like this: 1, 2, or there's not supposed to be a comma here. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And this would be a 3 by 3 matrix in math. Now, if you want to write the same thing in MATLAB, you need to consider two things: the row that the object is on, or the row that the number is on, and the column that it is in, or whether it is in a different row or something like that. In MATLAB, you consider two things, or let's say you use two things. First, you use the comma to separate values that are on the same row, and you use the semicolon to separate values that are of different rows. So if I want to go to a next row, I use a semicolon. So let's say, let me just write something over here. Use comma to separate values of same row. And another thing is, you should use semicolon to move to next row, right? So for example, okay, let me add a third thing. The first thing, obviously, we use square bracket to define arrays in MATLAB. Now, you actually put the values that you want in the array inside the square bracket. So for example, if I want to define this matrix that I have up here, what I would do is, in MATLAB, I'll just write my square bracket first. Then I'll write 1, 2, 3, right? All these values are in the same row, so I separate them with commas. Then if I want to move to the next row, I bring a semicolon and I continue 4, 5, 6, all on the same row. Then I move to the last row and I write 7, 8, 9. MATLAB. So this is essentially representing this array. This array in MATLAB. Now, let me just give another example. Let's say I want to represent a column vector of values 6, 9, 23, right? You realize that the values inside this are all on different rows. So if I want to write this in MATLAB, I'll write my square brackets, of course. I'll write 6, semicolon, 9 to move to the next row, then semicolon, 23 to move to the final row and write the 23 over there. It's actually very simple if you want to do this. Yeah. And yeah, we'll practice this just after the I'll put up my MATLAB, and then we'll just try and input the values so that we see how it works. This one I'm just using to demonstrate how it works first before we move to the editor. One last thing is generating the values. So I can generate the values over there. So let me just generate. Anyways, you use the semicolon to move to next rows, but I use a colon to generate values. So you specify a range of values. So let's say I do 1, semicolon, 5. It generates all values between 1 to 5. Essentially, yes. But you can also specify the difference between each number, or let me say the step that it will take as it moves from one number to the other. So let's say I want it to take a step of 1. So I'll do something like this: 1 semicolon 1 semicolon 5. This represents the step that you have to take, right? So this essentially will return something like this: 1, 2, 3, 4, 5. Generating numbers from 1 to 5 inclusively, moving at a step of 1, obviously. So the difference between 1 and 2 is 1, the difference between 2 and 3 is 1. 3 and 4 have a difference of 1, essentially, yes. So I'll go to my MATLAB right now, and then we just try and input just some values to demonstrate what I just said here right now. Yes. All right, so I'm here in my MATLAB, and yes, let's say I want to create the first one that I created, the matrix with 1, 2, 3, semicolon, 4, 5, 6, semicolon, 7, 8, 9, right? Let's say if I input this in MATLAB, I get this. This is that matrix that I drew up there: 1, 2, 3 on the first row, 4, 5, 6 on the second row, 7, 8, and 9 on the last row. The column vector that I wrote, I don't actually remember the values, so I'm only going to use different values, but you get the point. 45 semicolon 8 semicolon 0, right? This gives a column vector 45, 8, and 0, all in the same column but on different rows. Now you can also assign these values to variables. But anyway, before that, let's look at the generation that I'm talking about. Sorry, let's look at the generation that I was talking about. So you do 1 semicolon 5. If I do this, it actually provides a lot of values. Okay, no, the initial delimiter is 1, right? The initial step, that is the default step that's taken, is 1. So initially, to do this, but I can specify the amount of step that I want it to take, the difference that I want to be between the difference that I want there between the numbers, successive numbers. So I can do 1 is to 0.1 is to, I don't know why I'm calling this to. It's a colon, not is to. 1 colon 0.1 colon 6, something like this, to actually generate a lot of values. And yeah, you see. So they give column 1 through to 10, and they give values column this to 10, blah blah blah, and they give values. And if you look inside your workspace over here, realize that the answer variable has a matrix of 1 by 51. It has a matrix of dimension 1 by 51. So one horizontal row, obviously the rows are horizontal, so there's no need to say horizontal row. 1 row and 51 columns, or 51 different numbers in that row. Yeah. And just as I said, you can create variables for them. So let's say this is ages, a collection of ages, and I would like to input values over here. So I could say all ages from 13 to maybe 25. So instead of writing that, I'll just write this should be equal to 13 colon 25, right? You know, this would generate values from 13 to 25, taking a step of 1, right? So if I run this program right now, well, obviously, sorry, I forgot to not display it. I forgot to display it actually. Yes. So as I run it, you see that the ages range from 13, 14, up to 25, as I said. Or you can specify the difference that you want it to take. So let's say at intervals of 2, we do 13 semicolon, sorry, not semicolon, 13 colon 2 colon 25. And that should bring 13, move to 15, a difference of 2, move to 17, a difference of 2, and up to 25. You can even use this technique to generate maybe even numbers or odd numbers between a specified range. For example, if I want to generate all the even numbers from 2 to 100, I'll write my 2, and I know that even numbers, they have a difference of 2. So I'll write my 2, and then I'll bring my semicolon and let it take a step of 2 and move to the next one. And the last number should be 100, right? So if I create this and I run it, I'll get 2, 4, 6, 8, 10, 12, 14. You know the even numbers already, up to 9800. Alright guys, that's it for this video. I thank you all for watching. If you enjoyed it, please leave a like behind, subscribe if you're new around here, and I'll see you guys in the next one. Don't forget, this generation technique is very important. Peace.